Yeah, today I thought of taking two different types of class of algorithms. So one is called a random forest and the other one is a hidden Markov model. So I don't know, I will take these two algorithms. First I will finish one algorithms because lot of background informations are needed. So here the first one is called a random forest. So getting the basic idea of random forest, we should know 3 or 4 concepts. First concept, you should be familiar with the decision tree algorithms. Decision tree algorithms, that means you should be familiar with the entropy and information gain. So that is one part of this algorithm, and other part, this algorithm is coming under ensemble learning. So you should know what is ensemble learning and how we are going to use this ensemble learning concept here. So for that, again you should know 2 more concepts, that is what is called a bagging and boosting. So I thought of discussing first half an hour to 40-minute algorithms, then we will discuss what exactly this random forest. So first we will start with the ensemble learning. So because random forest is a one type of ensemble learning, there 2 concepts is coming. First one is called boosting and the other one is called bagging. Okay. So first we are going to discuss boosting algorithms. What exactly boosting? So boosting in the sense, we may have different hypotheses. So we have to considering individual hypothesis and you are going to take a decision, you can take a decision properly. So what we are going to do, we are going to club together those hypotheses, you are going to club together the hypothesis, you will get a better result. So that is the basic concept behind in boosting. I will tell you a very small example. Don't take whatever example I am discussing is, don't take it seriously, but for your understanding, just assume that for example tomorrow you need a holiday, or before Diwali you need a holiday for students, you need a holiday. Yeah, no, that I am not the right person for declaring it is okay, yeah. So in those cases, okay, this is, so for that initially what you will do, maybe one person you will approach your class advisor. So that is what is called the first hypothesis. Then your class advisor will tell something, maybe yes or no. Again what you will do, you will bring little more students and will approach class advisor. This is the second hypothesis. Second hypothesis. Then what you will do, you will take the topper in your class and again you will approach. Third approach. So now what exactly you are clubbing together those hypotheses together for getting a better classification. At last what will be the result? No, it's a yes or no, it's not a matter, but you will get a proper classification, either it's yes or it is no. So this is the basic concept behind in boosting. Okay, so boosting algorithms, ensemble, clubbing together the hypothesis. Okay, so now 10 minutes I am going to discuss how exactly this boosting algorithm will work with a small example. Okay, can you, yeah, you are the operator? Yeah. Okay, very good. And can you take yeah, this one? So I don't have any standard PPT, okay? Whatever I am using now, so others property only, yeah. Yeah, now here, first I will teach you how this boosting algorithm will work, then we will go for the mathematical part of that. So here, come down. The basic concept is, so sorry, can you come down? Come down please. Come down. Yeah, so now here we have 2 different types of apples. One apple is a plastic apple and other one is called our simile apple, just assume that. Now we need a classification for this. So for that we are going to start different hypotheses. Okay. Now how we are going to do that? Can you? Yeah. So this is the first hypothesis we made. So here, effectively, why we are calling this is boosting? It's a bootstrap aggregation. A very simple example for boosting is some students, they are getting 38 or 39, but pass mark is 40. What we will do? Here you can say this is our simla apple, this side it is a plastic apple. So one simla apple is in this side and one plastic apple is in that side. That means two misclassifications are there. Okay, two misclassifications are there. Getting or not? This is my first hypothesis. Now I am going for the next hypothesis. Please come down. This is the next hypothesis. Okay. Again. Now, like that, you have to fix the number of hypotheses. At last, you are going to club together those hypotheses. Clubbing together those hypotheses, we got a decision boundary. Okay. So this is the basic concept behind boosting. Especially for this algorithm is called the Adaboost algorithm. So this is the basic, this concept is applicable in our random forest algorithm, because that is also one type of ensemble learning algorithm. Random forest is one type of ensemble learning. This concept is called ensemble. Boosting is a one type of ensemble learning. Bagging is another type of ensemble learning. Okay, so we have different. This is one type of ensemble. Now, up to this point, clear? Any doubt? So we made different hypotheses, iterations according to computer science, that is iterations. We made a different hypothesis and we are clubbing together those hypotheses. Is it clear? Yeah, now, this one. Come down. Yeah, now we will take the algorithm for this. Okay. Now, here you can see n is examples. Examples in the sense, how many data points are there, how many classes. So, here two classes, either may be positive or negative, whatever may be, okay, 0 or 1, whatever may be. You can give two labels. So, y is called labels, n is an example. L is a learning algorithm generated, okay. So, we fixing the initial weight as 1 by 10, because n items, 10 items are there. So, it is a 1 by 10. So, that is for the D. Weight example, D is a distribution with the total weight should be 1. Then, now, we will come to the, now up to this point clear? Up to this point any doubt? So, we have fixed here, n is the examples, that means how many data points we have. So, y xi, x1 etc. yi as the classes, class labels. And here L is the learning algorithm generated the hypothesis. What is the total number of hypotheses? Okay, then T is the maximum number of hypotheses that we can fix it. And Dn is the weight. Now you fix the weight also. Now we come to the standard algorithm for this particular problem. Can you take the next step? Now this is the standard paper for this particular algorithm. Come to the algorithm part alone. Yeah. Now this is the algorithm. So this procedure is called the Adaboost. Now here given x1, y1, etc., xm, ym, okay, input data and the corresponding classes, and y is belonging to, is a two class problem, so -1 or +1 or 0 or 1. Then initialize d1 of I, that means first weights initializing, okay. So here that is 1 by m. How many data points are there? In our example that is 10, so 1 by 10, that is 0.1. Then for t equal to 1 to t, please fix the number of iterations. Now train a weak learner using a distribution dt, get a weak hypothesis ht. Now what is the meaning of a weak hypothesis? With a error, that means epsilon t equal to probability of I, that is going to following a distribution of ht of xi not equal to yi. Very simple. 10 class first hypothesis, please think about your first hypothesis. How many misclassifications are there? 2 misclassifications are there. So out of 10, correct? No. Then what is epsilon t? Say 2 by 10, correct? Clear? Out of 10, how many misclassifications are for a first hypothesis? 2 out of 10. So epsilon t, that is what is called the HT of xi is not equal to ii, that means it's misclassifying. So that is epsilon t. Now you are going to find then alpha t equal to 1 by 2 natural logarithm of 1 minus epsilon t by epsilon t. Now effectively you are going to update the weight, okay. You are going to update the weights. For that, initial weight is m, that is 1 by m, then you are going to update the weights. So here you can see new weights, okay, new weight, that is dt plus 1 of I equal to dt of I, that means old weights. Old weight is 0.1 in our case, 1 by 10 divided by zt, I will tell you that is a normalization factor, into e raised to minus alpha t if HT of xi equal to yi. That means here 10 items are there, out of 10 items 8 items are classified properly. So that means for that weight updation you have to use this formula. 2 items are not classified properly. So for that, those 2 items you have to use this formula. This is for a first hypothesis. Now that epsilon, normally this set t, we have different formula. Normally the people, they will use 2 times epsilon t into epsilon t minus 1. For a, this is just a normalization factor, okay. So that is for the first iteration. Now what we are going to do, please go for the next iteration with a similar algorithms. Once the weights will converge, there is no changes in the weights, there you can stop. So this procedure is called Adaboost algorithm. So this is a one type, any doubt? Okay, boosting. Now, any doubt? Yeah. Now another concept is called bagging. Can you take the original PPT which I made? Original one which I made. First PPT. No, this one, yeah. 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 Now, another concept is called bagging. It's a bagging also part of this. Okay. Now, effectively, what I mean by bagging? Why we are calling it a random forest? Why we are calling it a forest? It's a combination of trees. That means you are making different decision tree, okay, you are making different decision tree, randomly you are choosing the input, okay, randomly you are choosing input and you are using different decision tree. How we are going to consider different decision tree? That may be based on entropy, I will teach you maybe. Entropy, based on the entropy you can develop the decision tree, or based on the information gain also you can develop decision trees. I will teach you after 10 minutes, okay. So now here what exactly bagging? So different training data subset are randomly drawn with replacement. You are not going to consider, that means you are going to take different samples. You have an entire population, from that you are going to collect some samples. Using those samples you are developing different decision trees. What you are going to do? You have sample, from that sample you are going to develop different decision trees. For developing the decision tree we are using ID3 or Carrot algorithm. So we are developing different decision tree, then what you are going to do, you are clubbing together those decision tree and you are applying a majority voting on that. That is what your random forest will do, but I will explain. So here bagging is a different training data subset are randomly drawn with replacement from the entire training data set. Each training subset is used to train different classifier of the same type. Individual classifiers are then combined by taking a single majority vote of their decision. That means that concept is called bagging. So bagging is also part of your random forest, because at a time randomly you are selecting some data point, you are generating a decision tree and you are clubbing together those decision tree, at last you are going to apply majority voting on that. So this concept is called a bagging. So you should know what is bagging. Okay. Yeah. Now, what about this CART, this ID3 and CART? You are familiar with these two algorithms? Anybody discussed before this ID3 and CART algorithms? No. It's okay, no problem. Then please come to the end of this slide. End of this slide. Yeah, can you take the first one? Any doubt? Any doubt, please? Yeah. Which one? Bagging. Yeah. Can you take that slide? Bagging is effectively, like we have different data set. Okay. So from that data, what exactly you are going? That is a complete enumeration of the populations. Effectively, that means according to machine learning algorithm, our complete data set. Okay. From that complete data set randomly with the replacement node, that is what we are mentioning. Okay. Each training data set is used to different individual class are combined. Different training data subset are randomly drawn with the replacement. Okay. That means you have to fix the sample size randomly. Sample size. Then you have to pick randomly, and you are going to construct a decision tree. Okay. Now effectively, what exactly our random forest is doing? Now we have one decision tree, another decision tree, like that we have different decision tree. Now this is why we are calling this is ensemble. Now we are going to clubbing together those decision tree for getting a better classification. Is it clear or not? Then what you are going to do? We are going to apply majority voting on that. Clear or not? No. So that concept is called a bagging. Bagging is also part of random forest. Clear? Yeah, I'll explain again. Okay. Yeah, whenever we are discussing the random forest algorithm, again I'll explain. Yeah. Yeah. Now can you? Yeah. Now here, now we understood that you have to generate some decision trees. Correct? Now you have to generate some decision tree. So we have to check how we can generate a decision tree. So making decision tree, we have two different concepts. One is purely based on probability and other one is based on entropy. Okay. So based on probability, you are purely based on probability, that is what is called CART algorithm for generating a decision tree, classification regression tree. Another one is called calculating the entropy of the system, and based on the information gain, from that you are calculating the information gain, then we will generate a decision tree. So that algorithm is called a ID3 algorithm. So for our case, either you can use an ID3 algorithm for generating different decision trees, or you can use CART algorithm for generating different. Yeah. So now it's also, can you take this? Yeah. Come down. So this procedure is called this is a standard example. Okay, just for awareness. So here now like CART is purely based on Gini index. Okay, Gini index. So based on Gini index, you have to construct a decision tree. Okay, you have to construct different decision trees. So here a very simple example. This is a classical example. Okay, so here the Gini index, come down. Top. Now just assume that this is the data set. Can you go to the top? I am disturbing you, Balaji? Yeah, yeah. Come on, yeah. Here, now these are the different attributes. This is a very classical example, okay. It's a different attributes. Attributes, one is the outlook, temperature, humidity and wind. Based on that, you are going to take a decision. What is the decision? Whether you are going to play or you are not going to play a particular game. That is the decision, okay. That is the whether you are going to play or you are not going to play. It's a two-class problem. Okay, for that we are going. This algorithm is called CART. Come down. For that we are going to calculate a Gini index. So Gini index equal to 1 minus pi square. Okay, I equal to 1 to the number of classes. So we have to calculate the Gini index. For example, Now we take outlook, yes or no. Outlook you can take is sunny, yes 3, no, sorry, yes 2 and no 3. Number of instant is 5. Another one is called a sunny, sorry, this one, overcast 4, 0. Next one is called rain, that is 3, 2. Now, how we are calculating the Gini index? So, here for example, Gini index of outlook sunny is 1 minus 2 yes and 3 no. So, effectively 2 by 5 whole square minus 3 by 5 whole square. It is a Gini index. Now, a Gini index for a overcast is 1 minus totally 4 by 4 and 0 by 4 whole square. It is a Gini index for overcast. And a Gini index for a rain, that is 3 by 5 and 2 by 5. So, that is 1 minus 3 by 5 whole square minus 2 by 5 whole square. This procedure is called a Gini index calculation. Now, Gini index of outlook is totally 5 plus 4 plus 5, that is 14. 5 by 14 into the first value plus here it is 4 plus 0, 4. 4 by 14 into 0, Gini index is 0. Third case it is 5 by 14 into this one. So, this is the Gini index for the entire systems. Okay? Gini index for the entire system. So, you have to calculate the Gini index for entire systems. Yeah. Now, like this, you have to calculate Gini index for each and every attributes. We calculate the Gini index for outlook. You have to calculate the Gini index for temperature, and you have to calculate the Gini index for other attribute, humidity also. At last, you have to check what is the minimum Gini index. What is the minimum Gini index? That tree node you are going to expand. Okay? That tree node you are going to expand. Like that, you have to continue. Yeah, this outlook. Continue like this, come down. Yeah. Come down. Yeah. At last. Yeah. At last you will get a decision tree. Yeah. At last you will get a decision tree. Like this you have to construct decision trees with the different samples. Clear? You have to construct this is one procedure, okay. Like that another procedure is called ID3 using entropy, okay. You can develop a decision tree. This procedure, so now our decision trees are ready. Clear? This is one procedure for developing a decision tree. Now our decision tree is ready. Like this you can develop decision trees. Is it clear or not? Okay. Now we understood how to create a decision tree. Now we understood what is ensemble learning procedure. You understood what is backing. Correct now? Now we will discuss what is your random forest algorithm. Up to this point clear? Any doubt? Like this you can use entropy also for developing the tree, okay. Entropy, that is information gain, okay. Based on that also you can develop the trees. Now we got combination, what is that, plenty of trees with samples. Now we again go to our standard PPT, yeah. Yeah, this one, this is enough now, yeah. Can I use this now? Sometimes it is not working, biology. Yeah. Sorry. Now. Yeah, understood. Now we'll come to the standard presentation, okay. This one, yeah. Whatever doubt you have, you can ask, okay. Yeah. Now, yeah, yes. Which one? Backing. Backing, like we are classifying something. Yeah. So that randomly we are choosing that. Well, yeah, randomly.
Based on something, I need to tell that this is my hypothesis.
Which one? Which one? Not clear. N number of data sir, total data sir. Yeah. Yeah.
And I'm taking like making some cluster.
No, yeah. Yes. You are taking some samples. Okay, samples. Yeah.
But like it is why it is random.
Which one? No, why? Because what is the why we are using sample? Why we are using sample? Generally in statistics, because we can deal with a huge amount of data. Correct? No, we can deal with a huge amount of data. That is one reason we are taking samples. And other reasons, so no, like maybe plenty of attributes are there, or plenty of data points are there. That means plenty of instances are there. So here we can take the entire instances. That means some instances may not be suitable, or some what is that instances or some attributes are not dominated attributes for classification. This is one reason. Basically, why in computer science, why we are using randomized algorithm? Why? Because everything is random. Why we are using randomized algorithm? Assumption is very clear. Computational cost should not go beyond the average case. Effectively, that is the reason behind the randomizer. All other stories are supplementary. Computation aspect is computational cost should not go beyond the average case. That is the speciality of randomized algorithms. Don't go beyond that. Okay, that is the basic reason. That means computational cost is reducing. Okay, your doubt is clear or not? Yeah, that is why they are introduced bagging. Okay, yeah. Now, machine learning. Now, whatever machine learning algorithms. So we have a discriminative and generative models. Discriminative models are there, generative models are. That is why now you can see a lot of new research is going on this GAN, generative adversarial neural network. Generative adversarial neural network, that is one type of generative model. So we have a generative model, generative and discriminative learning are the key problems in machine learning. Okay, generative, whatever algorithm you have, either it's in generative or this is in discriminative. Yeah. For example, if you are asking, are there any face in the images? Discriminative model is sufficient. Then, if you are asking, find a three-dimensional model that describes the runner, use a generative model. So we have a discriminative model, at the same time we have a generative model. Yeah, Balaji. Yeah. So now, so here, what is the mathematics behind this? It's the probability of discriminative model either explicitly or implicitly study the posterior distribution directly. What is the meaning of posterior distribution? For example, a Bayesian classifier. What exactly you are calculating? Posterior distribution. Correct now? Posterior probability. Correct now? For example, a Bayesian, a very basic statistical machine learning is a Bayesian. What a Bayesian is doing? It is finding what is the posterior probability of this. Correct now? Yeah. So most of the discriminative models either explicitly or implicitly study the posterior distribution directly. What is the meaning of posterior? That means probability of a given B, that means probability of effectively a Bayesian. What exactly Bayesian is doing? It's calculating the posterior probability. Correct now? It's a posterior probability. For that, what we need a? We need a prior probability. We need a maximal likelihood, and divided by we need a evidence. So we need a. So Bayesian is calculating a posterior probability. So that's what they are telling. Discriminant model either explicitly or implicitly study the posterior distribution directly. Probability of x given y, comma p of y. A generative approach model the likelihood and prior separately. So that means a discriminative model is a clubbing together prior probability and maximal likelihood. That's what Bayesian is doing. It's clubbing together prior and a maximum likelihood. Prior and a maximum likelihood clubbing together, but a generative approach model the likelihood and prior separately. Likelihood, that means this data is following this type of distribution is separately, and the prior probability, okay, separately. So now some literatures are the discriminative approaches and some literatures are there for a generative approaches. Sorry. Yeah. Now we understood what is ensemble learning. It's a process by which multiple models such as classifier or experts as statistically generate a combined to solve a particular computation intelligence problems. That means here we are clubbing together the hypothesis. That means you have to see that whether your classifier is weak or not. When you will tell one classifier is weak? When you will tell one classifier is weak, classification rate is very low, then you can call that is a weak classifier. What you are going to do? That's why I am telling, okay, if one student is approaching classifier rate is very low. Clubbing together the hypothesis, you will get a better classification. Yeah. Yeah, primarily used to improve the performance of a model or reduce the likelihood of a unfortunate selection of the pure one. Yeah, when dealing with a large volume of data or lack of adequate data. Whatever doubt you have, you can ask me, okay? Yeah, go on, Balaji. Yeah. Now, so this is what is called. We have a different classifier, and so independently you are doing, then it's a lot of misclassification. That is why it is a weak classifier, clubbing together, and at last you will get a better decision boundaries. This is the basic concept behind in random forest or rotation forest or any type of forest algorithm also. Yeah. Simply. Yeah. Now you understood what is bagging. So this is a bagging algorithm. This you can learn. Okay. Now this is a boosting algorithm. We already discussed what is boosting algorithm. Now what is the time, Balaji? That means I can take hidden Markovian also. Possibly I am finishing this. Yeah. Yeah. Whatever doubt you have, you can ask to me. Okay. Yeah. Yeah. This is Adaboost. That also we discussed. Now this is also part of our ensemble. How we are generating an ensemble of a classifier is first train using bootstrapped sample of a training data, creating tier 1 classifier whose output are then used for a train a tier 2 classifier. So this is a random forest algorithm. Okay, I'll tell you how random forest will work. So here this procedure is called a random forest. Now concepts are clear. Now you have a m features. It's a very huge data set. Okay, then that you are going to divide samples. That is what is called a backing. You are taking different samples, backing, correct. Then you are going to construct a tree like this using CART or ID3 algorithms. So you have to generate different trees like this. Yes, any doubt? Yeah, so here you have different trees, one tree, second tree, third tree, etc., and take the majority vote. You can apply majority voting algorithm on this. That is what here. This is what is called as child. Now we developed a different random forest, trees, different trees using CART or ID3 or any other type of algorithms. Okay, entropy or any other type of algorithm. For that, we use the backing procedure for taking different samples. And this clubbing together is called the ensemble, and at last you are going to apply majority voting. Based on that you are going to take a final decision. So this procedure is called a random forest algorithm. So here the basic step is develop different trees using your data set. For that bagging, then club majority voting on that, getting a classifier. This procedure is called a random forest. Yeah. This is a step, okay, random forest, this is a simple algorithm. First start with a selection of random sample from the given data set, bagging. Then next this algorithm will construct a decision tree. Then in the step voting will be performed every predictor result, at least you are going to take a decision. This procedure. Yeah. Any doubt? Any doubt? Any doubt or clarification or anything, please? Implementation, I think you will take now. Yeah, they will take care of you, the implementation part. Any doubt, please? Is it clear? Clear or not? Not clear. Any doubt, please? No doubt. Yeah. Yeah. Which one? Okay. Okay. Applications. Yeah. Applications, like anywhere you can apply. In our what is that? I myself and one of my PhD student together we implemented. Okay, one paper in the malware analysis using this same random forest and another variant of random forest is called rotation variant. That means wherever very simple example you are finding, okay, you are applying some traditional machine learning algorithms, you are not able to get a good result. You are getting only 60% or 65% or something like that. Immediately you can go for one aspect is called ensemble learning. I am not telling only random forest, okay, rotation forest or a bagging or boosting or any type of, plenty of algorithms are there, okay. You can use different, plenty of boosting and bagging algorithms are there, so you will get better result. Okay. Then only you have to go for a deep learning procedure, okay. Not only of directly going for deep learning, it's not needed, okay. Most of the big data know this random forest algorithm will deal, because it's a randomized algorithm. Effectively it's okay, with all properties, it's effectively it's a randomized algorithm. That means automatically the cost will reduce, you'll get better result, okay. So like that any applications, wherever you are finding some problem with you are not able to get a better classification. Yeah. Any other Balaji? Yeah. Whatever doubt you have, you can ask, please. What's your doubt? Yeah. Applications, yeah. Random forest they can use because they are classification, because the problem is classification problem. Yeah. Practical? What you have to do? What you have to decide? Is it a prediction problem? Is it a classification problem?
Correlation based problem.
Correlation in the sense you are checking the attributes are correlated or not.
Like I have
only you are going to check that?
Yes, sir.
Then I think no need of going for this one, okay. Even now like a very simple covariance matrix, or maybe a PCA, or maybe ICA, or what is that, LDA, or maybe this singular value decomposition, or even with Karl Pearson correlation coefficient, lot of algorithms are for telling that. Yeah.
So they they have already used it. Like I was just asking how to use it.
Which one? Normally, like finding the similarity among the attributes. That's what you are telling. Is it like that?
They are like physiological signals. Like ABP, ECG.
Understood. Okay. Now you are effectively, what I understood, effectively you are checking whether these attributes are correlated or not. Effectively, that problem in machine learning we will call it as a feature reduction problem. It's not a classification problem.
It's a regression based.
Regression, okay. Well, yeah. So normally what you will do, PCA, LDA, or a very simple correlation coefficient. Only you have to check these two attributes are similar or not, or multiple attributes are similar. Maybe a Karl Pearson coefficient of correlation. Please check with the first attributes with the second attribute. First attribute, all combination of attributes. Then you can see that where we are getting the maximum coefficient, you can see that these two attributes are similar. Only that information is needed, then you can use some correlation. Or maybe you need further information like whether you are able to reduce the number of features, because similar attributes you can club together, then automatically you can go for a feature reduction algorithms. Okay. Then you can, okay, if you need a classification the next level, you can apply this. No problem, that is not a matter, okay. Yeah, that is possible, okay, yeah. Now your doubt is clear or not? Any other doubt, please? Yeah. Yeah, classification. Normally we will use for a classification. Now tell me what you mean by decision making.
For example, I have a different set of
Ah,
each has to be classified.
ah,
Then based upon the classified data,
yeah.
I have to do a decision making finding the set.
I think it's an optimization. Your question is whether you can use this algorithm for optimization. That is your problem? No, because it's either classification or optimization. Normally, no, normally, this algorithm normally we won't use for a optimization. Okay. Normally we will use for that. But your problem, because now I am telling this effectively this ensemble classifier, that function is there now. I made a function, correct? No, that is the classification function. Maybe your objective function of your problem, because it's an optimization problem. Yeah. You,
I have a different set of data. From the data, I have to find a site which is more suitable for a particular purpose.
more
Suitable for a particular purpose. It has different layers.
Okay, yeah.
So that it is best for classification.
Yeah, correct. There is no doubt for that. Yeah.
Decision making and the classification.
That's why I am asking what is the meaning of decision making. So decision making also one type of classification, correct? No, for example, doctor is getting some data. He is going to decide, okay, this is what type of cancer. It's a decision making problem. At the same time, that is a classification problem also. Am I correct or not? So this is suitable. The decision making, I thought your problem is an optimization problem. Your problem is not an optimization problem. Decision making problems, that you can use for a classification also. Even decision tree for a decision making only, whether you are going to play, because your problem is a multi-class problem. That is what I understood. Okay, it's a multi-class problem. Multi-class problem you can use this one, sir. Is it?
Then they will put each weight. Then after putting weighted algorithm, we get finding one particular. Same procedure.
Here they used a voting algorithm. There your weighting is called majority voting algorithm. So maybe weighted majority voting algorithm you can implement it. Correct? No. Here they used a voting algorithm. Maybe that you can replace with a majority voting is there, weighted majority voting is there. Now what you are telling, some attributes or some value you are going to give more preference. Is it like that? That is what is called weighted majority voting. Okay, that means some classes you are giving more preference, some classes you are not going to give more preference. Am I correct? Yeah. So that is what is called here ensemble. This random forest they are mentioned voting algorithm. That you can change into weighted majority voting algorithm. Maybe I think that may be one solution. If you have any doubt, you can come. Okay, we will have discussion. Yeah. Okay. And other solution is called apply some mixture models or something like that. Okay, maybe other solution for your problem. It's another solution. Yeah. Any other doubt, please? Any other doubt? Yeah. Any other doubt? Yeah. We'll start next also. Time is there now. Yeah. Yeah. Thank you. I'll take one more algorithm. Okay. Yeah. I don't know we'll get sufficient time or not. Otherwise, we'll continue. We have to give another 30-minute biology, not today. Okay. Today I'll take only up to 12:30. Okay. Only half an hour. Yeah. Okay. Yeah. Can you take that? Now, so here we have a Markovian process, okay, and at the same time we have a hidden Markovian process also. I think you are familiar with the philosophy. I'll tell you first. Okay. Here. Okay. So now, I think everybody know what is Markovian process. If you are not aware, then we will discuss with a small example. Okay. Yeah. So here, so Markovian process is defined by we have x1, x2, xn set of states, and n by n transition matrix for this. I'll tell you, describing the probability of transforming to state xj given that you are in xi. So this row must be, what is that? Rows must sum to 1, means, and the rows and columns together one, that is called a doubly stochastic matrix. That I will tell you later. Okay. Yeah. I will take a small example, then it will be very clear. Now, a very simple example for this this is also normally we will use for a prediction. Okay? Normally we will use for a prediction or classification problem. Now, for a very classical or very simple example for a Markovian process, okay, you are going to predict, given that a person last Coca-Cola purchase was Coke, there is a 90% chance that his next cola purchase will be also Coke. Okay, that means based on today's information, today is cloudy, what about tomorrow? Okay, so this procedure is called you are going to predict what is going to happen tomorrow based on today's information. Maybe after 2 days what is going to happen. So this procedure is called a Markovian process. So now here today you are taking Coke. What is the possibility for tomorrow you are taking a Pepsi? 0.1%. Today you are taking Coke, tomorrow also you are going to take, what is the probability? 0.9. And today you are taking Pepsi, tomorrow you are going to take Pepsi, probability is 0.8. And today you are taking Pepsi and tomorrow you are taking Coke, what is the probability? Yeah. Now Coke, what is the probability? Yeah. Coke to Pepsi, what is the probability? Pepsi to Coke, what is the probability? And Pepsi to Pepsi, what is the probability? This matrix is called now effectively you have to train this matrix. Train this matrix. So this matrix is called a transition matrix. Okay, in a Markovian process, transition matrix. Now this is not a great deal. Yeah. Now what is the real problem now? Given that a person is currently Pepsi purchaser, what is the probability that he will purchase Coke too? Now after 2 days, okay, second. After 2 days, what is the probability for? Yeah. Now what they are going to do? They are going to multiply that matrix 2 times. Okay. Then what is the value they are getting? Based on that, you can tell that whether tomorrow also he is going to use Pepsi or whatever maybe. Yeah. Now this is the third day or something like that. Now. Okay. Now this procedure, that means based on today's information, you are going to predict what is going to happen tomorrow or after 2 days or 3 days, whatever may be. So that procedure is called a Markovian process. Now what is hidden Markovian process? Markovian process is clear because based on the today's information you are going to predict what is going to happen tomorrow. So for that we have states and transitions. Correct now? Here what are the states? Here what are the states? Yeah, 2 states are there, Pepsi and Coca-Cola. Now what exactly a hidden Markovian process will do? Now here states are visible. States are visible. Correct. But most of the real-time applications, states are not visible but observations are visible. Okay, states are not visible or not exactly visible, but states are hidden but observations are visible. Observations are visible. So what is the meaning of observation here? Now just I am calling you, okay, just assume that you are my friend, I am calling you, okay, it's a holiday, now you are telling, okay, like I am taking bath, sorry, I am, what is that, washing my dresses, or correct, or cleaning rooms. Now what I 10 o'clock in the morning I am calling. What, this is an observation. What I am observing? Now I don't know what exactly, but I understood that 10 o'clock, yeah, that means minimum I can understood that today there is no class or you went to the, correct. So that is the states. Effectively I got some observation. What is observation? It's cleaning his room. Cleaning his room is observation, but based on that observation what I am going to assume? The state I am going to assume. What is the state? He is bunking the class or yeah, is absent or today is a holiday. Correct. So this procedure is called, that means in hidden Markovian model states are not visible, but we may have some observations. Based on the observations, okay, observations, you are going to classify observations, correct. So, that is procedure is called a hidden mark. Now, we will discuss one standard example. Okay. Any doubt? Yeah. Now, this is the standard example. Okay. This is available in Wikipedia also. Okay. Yeah. You can check that. Now, here consider two friends, Alice and Bob. Okay. Live far away from each other and who talk together daily over a telephone about what they did that day. Bob is only interested in three activities: walking in the park, shopping and cleaning his apartment. Observations. Okay, observations. The choice of what to do determined exclusively by weather on a given data. Here weather on a given data, okay, that is the states. That is the states now, okay. Other one is observation. Alice has no definite information about the weather, but she knows general trends based on what Bob tell her he did each day. Alice tried to guess what the weather must have been like. So, here observations are either it's a walking in the park. Walking in the park means the climate is clear, correct now. Climate is very clear, that is the states. And shopping, cleaning his apartment, climate is not good. That is maybe one reason he is not going outside. So, observations, based on the observations you are going to predict the states. So, that is what hidden Markovian will do. Is it clear? Yeah. Now, so here Alice believes that weather operates as a discrete Markovian chain. There are two states, rainy and sunny. She cannot observe them directly, that is, they are hidden from her. On each day, there is a certain chance that Bob will perform one of the following activities depending upon the weather: walk, shop or clean. Since Bob tells Alice about his activities, those are observations. Okay? States are not visible. That is why we are calling it is a hidden Markovian. Okay, so hidden, states are hidden, observations are visible here. Based on the observation, we are going to take a decision. Yeah. So, now here states are rainy or sunny, observations are here. So, here two different types of probability matrix are there. One is called the transition probability and other one is called the emission probability. Transition probability is related, for a Markovian process we have only transition probability, only related to the states. Here we have states related probability, at the same time observations are related states. Okay? So, those probabilities are called the emission probability. So, you have to find the, you have to update the emission probability, at the same time you have to update the transition probability also. Now, here rainy and sunny are the two states, walk, shop and clean are the observations. So, this is a hidden Markovian process. Now, so, in a traditional Markovian process only these two will be there, rainy and sunny. Okay. Apart from that, observations, which are the observations, and we have a corresponding probability. So, that side probability is called a transition probability and this side probability is called a emission probability. Initially randomly you have to fix what is the real work, at last it will converge and you will get a what is that, a converged transition and emission probability table. Based on that you can test whatever data you have. Yeah. So, for that different algorithms are there. Okay. This is one algorithm. Here effectively what you are going to find? You are going to find the parameters. Okay. Parameters. You should find the unknown parameter hidden Markovian model, iterative method for learning probabilistic characterization model from unsupervised data. Initially assume random assignment of examples of categories. Learn an initial probabilistic model by estimating model parameter theta from this randomly labeled data. Now here This is a standard algorithm. So, we have for a missing parameter, finding the parameter normally, especially for a missing data. What type of algorithm you will use? For example, now you have a data set, you got one data set, some attributes are missing, some attributes are there, but values are not there. Okay, values are not there. Then what you will do? You have to use some algorithm for finding missing values. So, for that we have a standard algorithm for finding the parameter. So, that is what is called a expectation maximization algorithm. So, this expectation maximization algorithm you will use for our hidden Markov process, also for estimating the parameters. I will tell you a very simple example. We will take 2, 6, 8, these are some numbers, okay, 8, this you do not know this number and this is 4, just assume that. Okay. Now, how this expectation maximization algorithm will work? A very simple algorithm. What it will do? Please calculate the average of this. 6 plus 2, 8, 8 plus 8, 16, correct now, plus 4, 20. How many attributes are here? Including missing attributes? 5. So, 20 by 5, 4. So, this missing data initially you are going to replace with a 4. That is what is called the expectation, correct. That is an expectation. Now, how you are going to maximize this? Again, recalculate the mean, okay. Recalculate this value, there is no changes in the mean value. That means this mean value will converge. So, that value you can take it as the missing attributes value. Is it clear or not? Okay. So, this algorithm is called a expectation maximization algorithm. Okay. This is a very simple example for expectation maximization. First you are what is expectation mathematically? Mathematically what is expectation? It is mean, correct now. Expectation is mean. So, you are calculating the mean. Then what you are going to do? You are maximizing the mean, correct. So, that is why we are calling it a expectation maximization. This is a very simple example, okay, but algorithm is not like this, okay. Yeah. Yeah. So, now effectively mean is a parameter. So, you have to maximize that parameter. So, that we are going to do it now. Okay. Maximization is an M step. Re-estimate the model parameter theta from the probabilistically relabeled data. Okay. Now, this case it is a simple mean. This case it is a simple mean. But most of the cases it is not a mean, that may be a distribution. Okay. That may be a, it is not a mean, that is a distribution, probability density functions. Okay. That may be a univariate or multivariate probability density functions. So, you have to find the probability density function and you have to find the parameter on that. For example, a normal density or a normal density univariate, this is a normal density. Okay. Univariate normal density parameters are mean and a standard deviation. So, variance, okay, parameters are mean and a standard deviation. Once it will become multivariate, mean will become covariance, okay, and variance will become covariance, and we have independent, each and every data we have separate mean, multivariate density, okay. So, we have to find those parameters. So, that is what this theta. Re-estimate the model parameters, whatever parameter you have, each and every address you have to calculate what is the new mu value, what is the new sigma value, correct. Re-estimate the parameters. Now, yeah, that is what here we are doing. Okay. So, here x1 maybe RG or maybe for an images RGB or something like that, okay. Images x2, x3, etc. That is a EM class, this is an EM expectation maxwell. So, for that each and everything you are modeling using a maybe a Bayesian probability of C1 of x, Cj of x, etc. For that just assume that it is a multivariate. It's a multivariate. Then you have to calculate the parameter. Just assume that this is going to following a normal distribution. Your data is going to following a multivariate normal distribution. So this is the corresponding density function. So this will become sigma 2 pi. Then this will become xi minus mu transpose into xi minus mu, and this will become, maybe we can take 1 by 2 outside, and this will become sigma. Okay, multivariate. So this parameter, so each and every data, those parameters you have to calculate. That's what they are telling. Cluster the parameters of mu1, sigma 1 for a particular data, class 1, mu2, sigma t, etc., mu k, sigma. Now this is input, and these are the parameter, and you can find what is the density, or what is the, clear or not, distribution. Okay, this is the distribution, because we are giving an input to the system, are going to define this is the distribution is going to follow. You are calculating the parameter and recalculating the parameter, and you are fixing the distribution. That's what here, and you will get a classification whatever data you are giving. Yeah. Now this is the expectation step. Expectation step in the sense, here input plus estimator parameter, then you are going to tell what is the class. What is the class? For that, what is this? Posterior probability are calculating. It's a Bayesian. Posterior probability equal to prior probability into likelihood. So this is a likelihood. This is a likelihood. So this likelihood only, this density. Okay, this likelihood only this density, and this is the prior probability, non-probability. This is the total, this one. Okay, total this one is an evidence. Okay, that means summation. Total of this is complete. It's called the evidence. So that is a, you calculate in the posterior probability, and you can classify whether belonging to this or that or anything. Now, yeah. Now this is the maximization step. Maximization step in the sense you have to calculate the parameter. Okay, there you are calculating the classes. Here you are calculating the parameters. For example, here it is mu and a sigma you are calculating. Okay, then re-estimating. So this is the maximization step. Okay. Now here this entire complete step is called a EM algorithm. First part we are expectation. Each step is executing, finding the classes. Second step, recalculating the parameter. Okay, maximization step. This together is called a, this is one algorithm for finding the parameter in Markovian process. Other we have some standard procedure also. Okay, I don't have that material with me. Some standard procedure also, that is a little bit simple. Okay, standard procedure also, therefore calculating the parameters. Okay, that PPT I don't have now. Okay, yeah. Time is there. Yeah. Any doubt, please? So here, effectively, like we discussed two different class of algorithms. Normally, in any machine learning algorithm may be supervised, unsupervised, ensemble, or a reinforcement. Okay. So that third one, or what is that? This random forest is coming under ensemble, and this is coming under reinforcement learning. A lot of algorithms are there. Okay, in reinforcement also. Now, a lot of research is going on this reinforcement learning also. Deep learning, like deep learning, lot of research is going on, especially for this combination of reinforcement learning with the game theoretical approaches. Okay, lot of research is going on apart from deep learning and generative adversarial neural network. Okay, that is one direction. Lot of research is going on. Another direction, this what is that? Maybe in the next level we will no, yeah. This I think is a basic level. Yeah, that's what they are telling. Okay, yeah. Any doubt, please? Any doubt, or please? Yeah. Any doubt, please? Any doubt? It's not clear, Markovian? Concept is clear now. That the weight updation or some other updating the transition matrix, okay, how they generate in the transition matrix. That is why I requested him to give, he was given only 1 hour, then he extended 2 hour, now he reduced again 30 minutes from that, okay, that is not my problem, correct no? Yeah, as I request him to give 3 hours. It's okay, no problem. Okay, maybe in the next section we will discuss how exactly we are updating the what is that weight matrix for hidden Markovian process. If you, okay, yeah. Any doubt, please? Any clarification, please? Nothing. Application or like if you are a lot of applications are there. Okay, because you have to see that in your application is a time dependent. Whenever you are applying machine learning, you have to see it's a time dependent or time independent. Okay, that is very important. Okay, correct no? Very simple example, ice. Okay, now you are in Ooty, you are going to Ooty and you are selling ice cream free. People they won't purchase. Why? They won't take it. Even free also they won't take it. Why? Yeah, it's you have to see your application is time dependent or time independent. Correct no? At the same time, you have to see that okay, so memory is needed. For example, even deep learning, some algorithms no need of memory. Alzheimer's, most of the neural network algorithms are Alzheimer's. Correct? No need of memory. But some algorithms we need, that's why LSTM, no, like general recursive neural network algorithm. I will discuss that. So we have to see, whatever may be the application, see that time dependent and time independent. Okay? So that is important.
We are always talking about 2 streams.
Which is
deep learning. So in your perspective, where deep learning fails and how we are exploiting the name machine learning and moving towards deep learning? Unnecessary movement towards deep
No, like now I can tell you one thing. Okay, even we have a very small. Now your purchase. What is the cost of your computer? Maybe 70,000. 70. No, I'm asking your laptop.
My laptop. I have 2 laptops.
Yeah, that's what. But yeah, but I'm not insulting you. But what work you are doing with that? No. Effectively same problem I'm also facing. And I'm not. This is the reality, Balaji. I'm telling you. Okay, the fact I'm telling you. I'm not telling to you about you because I purchased a laptop. Just I'm watching some film. But for that purpose, we need that much high-end laptop. It's not needed effectively. Effectively, even with you have a very small data set, even then you will speak about deep learning. You will speak about what is that parallelism. What is that? Big data and other stories. Correct? No. So you have to see that one thing you have to see that whether your data is very huge. At the same time, you have to see. Okay, I'm trying to answer your question. Okay, yeah. At the same time, you have to check whether your data is heterogeneous or not, because that is very important. Heterogeneous data, no, those because no, like deep learning now. Why we are applying deep learning? Most of the cases, data is very huge. At the same time, you are not able to understand the features properly. Correct? No, and the data is heterogeneous. For example, in security aspect. Different what is that the devices are there. Each and every devices is developing different types of data. You have to canonicalize or bring together those data. So those type of problems, like that may not be easy. Correct. So maybe correct. So that's why I'm telling you, you have to see that your problem is heterogeneous. And one more thing, even deep learning, because most algorithms are different. For example, the recursive neural network where you will use, you should know. That's why I was asking whether your application is time dependent or not. Means minimum you have to check, okay, for example, natural language processing, because sentences are connected. Correct. Memory is needed. Yeah. Some application attributes are correlated. That is why convolution neural network normally they use for image processing. That may not be applicable for a security problem. Test also it's good. But security problem, convolution neural network normally we won't use because we can't find the similarity among, because here pixels are similar, correct now. But so depending upon autocorrelators are different. So everything is depending upon the different application. Yeah. Now your question is clear. Maybe like you have an heterogeneous huge amount of data, and you are directly, you can't extract the features from that. Some other what is that directions also there. Maybe in the next, if you are calling me, then we will discuss that. Okay, in the next what is that next series. Okay, yeah. But this is the reason. But everybody simply we are using deep learning and take human algorithm and one more problem. Most of us know we are not learning what exactly happening in the deep learning also. Just we'll take the tool and we'll get a nice result. Oh, super. No, correct, no. Even I can tell you one thing, one of my students, okay, like he was working with the deep learning at the same time ensemble learning. Then he started with this autoencoder and other stories, but that are not providing nice results. Then I told him just you can check with any type of ensemble learning, immediately got the result. This same random forest and rotation forest or something like that. Yeah. Even Adaboost. Okay. So that
Most of the people, they want
no problem, no, like now no, like everything is a fashion. Okay, fashion. Okay, today they'll introduce one, everybody will, okay, oh, this course I need or this one I need. Okay, then tomorrow you forget that, tomorrow something else will come.
that's the reason why I asked.
That that I don't know, but anyway, this is the, so you have to see that whether really you need a deep learning for writing a calculator program, you need an i7 system or not. This is the question. Okay, like or your system is sufficient for writing a what is that calculator program. This is the question. You have to see that. Yeah. Thank you. Yeah. Thank you. Okay. Yeah. Thank you. Yeah.